Hello and welcome to Microservices March. We're in our first unit out of 4, apply the 12-factor app to microservices architectures. My name is Jen Guile. I'm with Nginx Product Marketing, and I'm going to introduce the session and then hand it off to the speakers. So a couple housekeeping notes first. If you are interested in earning our Microservices March badge for 2023, the requirements are to attend all 4 of the webinars, either live or on demand. So they air each Wednesday at 8 a.m. Pacific, and then complete all 4 of the hands-on labs using the same email address for both. And so if you're attending right now, you're gonna check off the first webinar and the first lab. Another reminder is that we have the Nginx community Slack, which you can access through the On24 menu. If you join the Microservices March channel, that's a great place to ask questions about the content, get help with labs if you're doing it on your own, and connecting with our experts, including the speakers. And then let's dive straight into today's agenda. We have 2 experts from Nginx who are going to be delivering roughly a 45-minute lecture on the topic of adapting or applying the 12-factor app to microservices architectures. That's going to include a Q&A portion. So you'll notice in On24, there's a place where you can add questions. If you add them in the chat, there's a chance we might get to them, but no promises. So definitely use that Q&A. We'll answer throughout if there's something that's relevant to what we're talking about. Otherwise, we'll hold questions to the end. And then the remainder of the session will be time for you to complete our hands-on lab. You don't need anything other than the browser that you've logged in with today. And then our experts will be hanging out to answer questions, troubleshoot, whatever you need during that time. If you are watching on demand, that part of the video will be cropped off. And so if you have questions, you'll just come back to that Slack channel. Without further ado, I'm going to go ahead and introduce our speakers for today's session. We have Javier and Jason. They're both from our alliances and community team in Nginx. And maybe you two can start off by telling the group what your experience is with microservices, what you do for Nginx, and then we can jump in.
Thanks, Jen. My name is Jason Schmidt, or Jay, and my experience has been primarily on the operational side of things. And as we'll find out in the lecture here, my career spans the time before microservices and before the 12 factors. So it's very interesting career arc that's giving me some interesting insights into the microservices.
My name is Javier Evans, and my trajectory is kind of I'm the other part of this odd couple. So I come more from the web application development side, and I've been working with that for the past 10 years or so across small and medium-sized companies. And for the past, I'd say 6 or 7 years, I've been operating exclusively in microservices environments. So with that being said, let's jump into the talk itself, and we'll give some background, and then we'll jump into a demo where we'll sort of give an example of a lot of the stuff we're talking about. But when I first started, about, like I said, 10 or so years ago, that was still a time when we would, a monolithic app was what we shipped. We'd all talk about when we're going to deploy, and then at some point, I or someone else would walk over to an actual desk and tell a person, "Hey, I would like to deploy the application now." And then they would go do a bunch of manual things to deploy them. So although I have memories of that time, I was working in the Ruby and Rails community at the time, and that's kind of where the 12-factor application guidance came from. And so we were actually doing a lot of those things at that time already. So I come from the group of people that can't really remember when the 12-factor guidance wasn't just how you did things.
For my point, I came in, my first job was actually systems administrator of a mainframe, and that was definitely not microservices and definitely not 12-factor. So, the first part of my career, I did a lot of things that were common practice at the time. But when we get to the next slide and look at the 12 factors, a lot of those 12 factors are the things we would talk about at lunch or we talk about after work. And like, why do we have multiple code bases? Why do we do things this way? And the answer was usually this is because how we do it. So when the 12 factors came out in 2011, it was interesting in that a lot of this is like, yes, these are things we've been talking about. We should probably try and do these. And I've put a couple notes on the slide here, and we talk about web scale. That became a thing in the 2000s. This stuff is all best practices today, and I think one of the most important things is the agnosticism it has towards language and backing services. No matter what language, what backing service you're using, the 12 factors have a role in your application. And the quote I've pulled out here, I think, is one of the best ways to succinctly describe what the 12 factors are for. They're principles that describe a way of doing things where we can release our code quickly, we can scale it, and we can maintain it, and we have predictability.
And so just in case you haven't been exposed to the 12 factors recently, we're going to throw them up here for you to look at. And we'll talk about a few, but I mean, to talk about some that kind of have been common industry practice for as long as probably all of us can remember now, except for, I guess, Jason. Things like, having one code base. We're not having a separate code base for your staging environment or your test. You don't have a test code base and a production code base, right? That's pretty much how things work now. Now, something like dependencies might be a little bit more, recent. So the guidance is, hey, have your dependencies explicitly defined. Don't depend on them being there. So in my world, we've always had some file where we wrote down all the dependencies that the application has, use semantic versioning to determine how we update them and when they get updated. And then there's a lock file generated to make sure that we're getting the same version of those dependencies that we tested against.
And that is something that is new to me. Like just covering the first two factors, the code base and dependencies. Many of my jobs, part of it was making sure that the dev code base, the QA code base, the test code base, and the prod code base stayed somewhat in sync. And why did they have differences? A lot of times it was dependencies. So, for example, using old data general systems, some were Motorola based and some were Intel based. So, hey, QA runs on Intel, but dev runs on Motorola. So we had to compile for different architectures. So, these are all things that were like, and blindingly obvious in retrospect. And I think some of the best discoveries are that way. But it does address a lot of the problems that I would fight with each and every day.
All right. So getting into why you might do the 12-factor practices in your application. So the 12-factor guidance is really about enabling the core principles that you see here on this slide. So, scalability, resilience, and security, and among others. And at the time, it was just, as we've been talking about, and Jason will talk about it a little bit more in the next slide, that was a big transition going from not doing all these things to having these practices that let us kind of make our way closer and closer to that type of state where we're in a good place with resiliency and continuous delivery. But it's important to note that the change from having monolithic applications to working in a microservices architecture, as far as that hasn't been as large a change, I think. I mean, the reason that we're introducing this idea of microservices is really still in service of the same principles. We move to microservices because we want more scalability in certain areas, that we want resiliency in certain areas. So although we're making a change with how we do things, a lot of those 12-factor app practices are still applicable because we're going at it with the same goal in mind. But what we've learned since we've been doing microservices now as an industry for almost 10 years, I'd say, in terms of having it be a common thing, the primary consideration about choosing microservices is really your organization and how you want your teams to work together. So microservices, principally is designed to help teams execute on their individual goals all by themselves without having to depend on other teams, for example, while at the same time providing sort of a framework for them to use to collaborate. So as we think about how to adapt the 12-factor guidance to microservices, will have mostly the same considerations, and these core principles aren't going to change, but the concrete form of the implementation is going to have differences because we're now dealing with this slightly more complex human problem, although the technical goals are still the same.
So this is my slide, and this is my version of how bad things were back in my day. And before we start on this, I do want to point out something that Javier said, just to draw attention to it. The evolution was applying the 12 factors and then moving into microservices as a way to leverage those 12 factors. But before then, I would call this the age of the monoliths. And I've performed all these roles before, and as developers, your landscape involved tightly coupled applications where 4 different teams would share one library, and if you made the wrong change to that library, you broke everybody. And external dependencies on the hardware and OS, like I was talking about, if you're deploying on all sorts of different Unix and Unix-like OSs on different architectures, you may not have the same development system as you do in production, or you may require specialized hardware that's so expensive that we only have one copy of it. As an operator, this is the age of managing the bare metal servers. You'd rack and stack your servers in your data center. You'd wire them up together. If you needed to scale an application, you put a bigger server in and migrated data, or you cracked the server and put in more memory or CPUs. And then as an operator, everybody has that pager feeling when the pager goes off and there's a reboot happening. And reboots were always a cross your finger event because you didn't know if things were going to come back up in the correct state. And then this led to release management. Releases were big events. This is our big event release. We have a code freeze, and then we're going to release. And these often resulted in unscheduled downtime. So you'd ask for a 4-hour maintenance window, and then 2 days later, the CEO is asking you what happened. And this points to the overarching problems that we had back in these days. The importance of tribal knowledge. You needed to know that Gary over in operations made this one change to Shem Max that now needs to be replicated on these other machines. You didn't have much documentation. There weren't many procedures because everybody was kind of doing things on the fly. And then something that I personally hated was the change management boards, which a lot of times were composed of senior management and even executive management, where they had no idea what the changes were, but they had to stamp them as okay or not okay. So these are all the things that were going on when the 12 factors came out and we started to evolve to that. And I point this all out because I think that we can all agree this was a change for the better.
And Jason had to actually explain to me what a change management board was. I feel a little bit lucky that I didn't have to go through that particular one. All right, well, so for today, we're kind of going to get a little bit more into what we're going to show you today. And for today, we've chosen one of the factors because I think this is one of the factors where I've seen practices in microservice architecture environments that I've worked with that are interesting in terms of the new way that we deploy and ship applications and the 12-factor guidance. So we're going to focus on how the 12-factor app suggests that we handle configuration. And configuration in terms of the 12-factor app is basically, hey, be loosely coupled. So configuration should be strictly separated from code. The 12-factor app also tells us that we should use environment variables. At the time, that was the guidance, environment variables, to provide configuration values to our applications. And we'll see concrete examples of all of this as we move forward. But what's changed? We've got infrastructure as code being a big part of how we work. So in a microservices environment, your team now has moved to managing, for example, one of the basics of microservices is if your service has a data store that it doesn't share with anyone else, your team will manage that data store. We also have the emergence of container orchestration management systems where, like Kubernetes or HashiCorp Nomad would be another one that's maybe lesser known. And those also have files that your team is going to need to manage themselves. And all of this is kind of in the spirit of Factor 3. And as I said, we'll give you concrete examples as we keep moving. But, honoring that service ownership, it's really important in the microservices context that your team has the power to do everything related to your service to get the goals achieved. And also the processes that your team uses to ensure stability in production, such as code review. And really a big piece of this is reducing cognitive load. You've got technical cognitive load and cognitive load from, interacting within your organization and planning things. And the goal is to kind of keep that all down. And we'll look at how we're going to achieve that through how we manage configuration.
And before we get to the supporting factors, one thing I do want to draw out from the last slide is we say at the top that this is guidance. And what we mean by that is these are not completely ironclad rules that you need to follow in all cases and in every case. What you need to do is you need to understand why that's a factor. You need to understand how that impacts your system or your service. And then if you break the rule, you need to have a good reason why. And there are reasons out there. But I just want to implore people to, treat these as guidance, and kind of the overriding factor over all of this, the uber factor, is that there needs to be communications between the various teams. The 12 factors work best in a transparent environment where there's the ability to fail and there's the ability to communicate with what's being tried and what's not being done.
That's right. That's a really good point. I see people getting very militant about, oh, you're not doing 12-factor right. And again, it's all, just like all software engineering, it's all about your current situation and what works best for your team. As we go into so just before we move forward, and there's other factors that support this, right? So a lot of the stuff we're going to introduce is dependent on good application of some of the other factors. So if you're running a microservices environment, really, in a monolith, we would have, I remember when I worked with monoliths, we would have sometimes 1.5 hour CI build times, or running all the tests and building the final thing that we would release would take over an hour. And then getting it fully deployed might take another hour to get all of the instances of the application rolled over. Likewise, disposability, you're not having any data stored in the actual instance, you're moving that all off so you can take them up and down as quickly as you can. And so this all kind of is tied up in just being able to roll forward really fast and not having it be a big deal. The backing store, as I mentioned before, this is kind of one of the biggest surprises that was apparent to me as I went from a non-microservices situation into one where I had microservices. It's just the responsibility that your team has now for managing things like data stores. You might have AWS S3 buckets that you're responsible for, message queues, that type of thing. And just the overarching factors get back to some of the things that we're trying to solve with microservices, which is mostly organizational. So you've now got, instead of one big monolith where everyone kind of understands all of the assumptions, you've got a bunch of services. And so it's really important to have clean contracts, interfaces, and just making sure that you treat the other teams in your organization like customers. And so there's a lot more sort of rigor that has to go into how you project your application outwards, which we'll get into in the demo. And so what we're going to do is we're going to introduce 3 patterns that I've kind of seen. The first one is and this is, again, related to, not explicitly a part of 12-factor, but related, which is, you got to really pay attention to how you are representing your application outwards. So we're going to make a configuration schema that's going to really make it clear to anyone, either members of your team or people coming in from outside, what the application needs to run. The next is that we're going to explore a pattern that I've seen in many of the places I've worked, where you are grouping your infrastructure and deployment code alongside your application. We'll talk about how that works with the 12-factor guidance. And then third, we're going to talk about using service discovery to make sure that your application is able to be sort of load balanced, and we'll use Nginx for that. And that'll be the piece of configuration that we send out into the system for other services that depend on ours. And in order to do that, we'll think about configuration in this way. So we'll think about 3 types of configuration. And these aren't formal definitions. This is just what we're going to think about as we're going through this demo. The first is application level configuration, which is not what the 12-factor is talking about. It's stuff related to how you configure your framework. It's not stuff that changes between, say, staging or production. We've got deployment level stuff, which I'm just going to define as like stuff that when you are sitting there in your text editor or IDE writing the code. And this is stuff that'll go through code review and that kind of thing. And then the third type is stuff that you will need your application to pull from an outside source at the time it is deployed. So, It might be stuff like secrets. Obviously, you don't want to be hard coding secrets into your application and checking them in, or things that you don't know the state of when you're writing the code. Like if you provision a database, you may not know specifically what the host name or the port that you can access that database on is until after it's provisioned. And so with that being said, I'll jump into the lab, but I'll give some kind of background first. So here it's going to be an interesting lab because we are not going to be showing you Kubernetes configuration or anything like that. We are going to try to be as framework free as possible, which means that we're going to be trying to show you concepts. We're going to be using things that play the role of those Kubernetes files or those Terraform files in order to illustrate concepts. And we want that so that everyone, even if you don't have deep understanding of Kubernetes, can come in and understand. We've also, if you look at the application code, you'll see that maybe it's not written in such a way that you would actually deploy to production, and that's on purpose, so that people who want to go look at the code repository later I've kind of tried to keep things all in one file so that you can go and not have to hunt around for things. So those are kind of the caveats on the lab. I'll go into the pieces of the architecture of what we're going to set up. So from top to bottom, we've got an Nginx reverse proxy and load balancer, which is going to be routing traffic to multiple instances of this service called Messenger, which is a basic chat application. And Messenger, in turn, will be interacting with a database, which is a Postgres database. And it'll also be connecting to a RabbitMQ message queue. And throughout all of this, we'll be using Consul both as a service discovery tool and a distributed key value store to stand in for sort of some configuration management system, and also help us keep track of what instances of the Messenger application are healthy and ready to receive traffic. So with that being said, let's jump into looking at some code, and we will show you some examples here. So the application that we're going to show you, and now let me wait to make sure that my window is actually showing up. There it is. The Messenger application is a simple Node.js application, and it uses the Express framework, and that's all we're going to know about that for now. But I want to draw your eyes to line 17 right here. So this is an example of that first type of configuration, where it's configuration to our application, and this is not what the 12-factor app is talking about, but it is configuration, right? It tells our application, hey, when you receive a HTTP request and it's of type JSON, decode that body and make it into JavaScript objects that we can deal with. This is not something that you would want to change between, say, staging and production, so it doesn't really fall into that category. But we can introduce some configuration to that configuration that we could, maybe want to have change between different environments. And it'll be a little bit contrived, but let's roll with it. So here I've added some configuration that limits the size of the JSON body that the application will parse to 20 bytes. So if the JSON body is too large, it's going to reject it. And let's see how that works. So I've saved this file. I'm going to go ahead and run the application. And you'll see it's listening on port 4000. And then I'm going to, I'm going to run a request against it. And you'll see here that I'm sending a JSON body that is under 20 bytes. It's just text hello. And so we'll see an error, but this is actually a good error. This error shows us that the application parsed the JSON payload, and it determined that it wasn't the right payload, and it rejected it. So that means that we send it the correct amount of JSON for it to parse. Now, if we send a request that's a little bit longer, so I've changed it from hello to hello world, this is going to exceed the 20 byte limit that we hard coded into the application code. And so if I run that, you get all this HTML. But the most important thing to see is this payload too large error. So this tells us that that configuration that we set here, saying limit the amount of JSON that you'll parse in a request body to 20 bytes, is working. So let's get this set up to be a little bit more flexible and in line with what 12-factor expects from us. So in order to do that, let's talk about that first sort of principle that we introduced earlier, which is we want to be really, really clear about what our application needs, both for our internal team, because I can't tell you how many teams I've been on where people are hired, people quit, people are transferred from other teams. So even internally, being really, really clear about the base configuration of your application has benefits. And I'm using this library. There's probably similar libraries in other languages called convict, and it allows us to specify all in one file, all in one little, it's all in this variable here, a schema for the configuration that the application needs to run. And I'll kind of run through what it looks like. So you have this name this is how you're going to refer to that configuration value inside the app. The thing I love about convict is that it forces you, it's not optional to provide a human readable description of what the configuration value does. And this is really important for that outward documentation part. It allows you to specify a format and it'll do conversions for you. So in this case, it'll say if what you give me for the Postgres database port doesn't look like a port, I'm going to throw an error, which is great. You want your application to fail if it gets a bad configuration like that. And most importantly, it tells us what environment variable it's going to look for that value under. So now that we know how this works, let's try to set up this piece of configuration here, this 20 bytes, to be adjustable in different environments. So in order to do that, I'm going to add another piece to my schema called JSON body limit. And I made sure to give it a really descriptive, human readable name that kind of tells you if you're going to change this, here's where you might look to understand the format. And most importantly, again, JSON body limit. This is the environment variable that my application is going to expect this value to come through it. Now, in order to wire it up 100%, we're going to go back to that main application entry point where we've hard coded it here. And we'll replace that code with this code, which just uses the value, the configuration library to pull in that named piece of config and provide it to the limit configuration there. So with that all set up, we'll jump back to the command line and we will stop our application and we'll start it again, this time with that JSON body limit set in the environment, and we'll set it to 28 bytes. So it's up and running, and then we'll rerun that command that just failed. So it's too large, that hello world. So we'll run that and we'll see, again, this error is expected. It's good. It means that the application was able to parse the JSON body. So that fixed that problem. But now we can go back here, stop it, and then we'll go and change the value to 8 bytes instead of 28 bytes. So application's back up and running, and we'll go back and run that smaller text blob that says text hello that was always working. And that one will give us the payload too large error, obviously, because it's over 8 bytes, and we were able to change it here without jumping back into the application code. So now I have the flexibility just from the command line or wherever the application is running to define that environment variable differently and have a change happen. So this is now us in the, we are in the situation where we've set our application up to be a traditional 12-factor application. We can provide configuration to the application without touching the application code. So now let's take a look at, this other pattern, which is more in line with, this is kind of the biggest change I've seen with microservice architectures. And, I'm going to be creating a bunch of files while I talk, and I'm not sure, Jason, if you want to butt in on anything, feel free, but I'm just going to keep rolling here. It's this idea of having next to your application a folder that has, it's usually called infrastructure. It might be called infra. I've seen it called deploy in different contexts, but it's basically a folder that maintains all of the code that has to do with the deployment of your service, as well as the supporting infrastructure that your service has. So that, if we go back and look at the diagram of what we're working with, this kind of says, here's how you deploy the messenger service, and here's how you provision the database, maybe in your cloud provider. So in real life, let me show you in the code editor. If we look at, we have infrastructure here, and I've created some files, which I'll go over in a second. But this might contain, in the real world, we're going to use some kind of fake files that play the same roles but aren't as complicated. But in the real world, this would contain stuff like maybe Terraform scripts to provision your database. It might contain Kubernetes manifests, like Kubernetes deploys or Kubernetes config maps, or just anything else that's necessary to deploy your application. So
the important there is, let me jump in for a quick second, Javier. This gets us away from the dependency management, and I think everybody has experienced the, well, it worked on my laptop problem where, it works great for the developer, but then when you go to deploy it and test or production, it fails. So this is all about keeping everything we need to deploy our application in one place so somebody can pull it and run it, and they should be able to run it just as well as you do using the same files.
Right. So we'll give you an example here. And I want to stop here and talk about this because this may not make much sense looking at it initially. But what I'm doing here is I've divided this file into two pieces. So the first piece is just, I just want to have all the variables, the configuration values that we're going to set defined as bash variables up here. So I'm setting JSON body limit to 100 kilobytes. And then down here, I've got a Docker run command. And you can kind of ignore most of it. The name of the container I'm going to run is messenger. But the part I want to draw your attention to is here. We're saying, okay, in this container, when it runs, make sure that there is an environment variable in the container called JSON body limit and set it equal to the value of JSON body limit that I've set up here. So these two are connecting. And what this is illustrating is, this is kind of what happens when you're running something in Kubernetes. Not exactly, but like, you are providing the system with some description of configuration, where it should come from or what the values are. That framework is kind of computing those for you. And then at the end of the day, it's starting a container. And so it's going to start the container, and the values of your configuration are going to be made available to the container. So this is the sort of core concept that this is a core concept of what's happening when we something gets deployed through that big complicated machine that's something like Kubernetes. So, and there's some benefits here, right? So if you look at this is something that I'm going to check into my, source control. And so it's going to go into the process of my team. So I made this change to the application code. And then next to it in the same code review is going to be where I set it for the deployment for production, for example. And so whoever is reviewing that can look at it and say, oh, I don't know, Javier, 100 kilobytes seems a little small. Are you sure we don't want to go up to 150? And I can say, oh, no, I looked into it, so we can have those type of discussions to make sure that, our deployments are as risk-free as possible.
And Javier, if I can jump in real quick here, and this is, we're so used to being able to do a git blame and see who made a change. And this way, we talked a bit about the tribal knowledge that is necessary back in the bad old days. Now it's right there. So we've defined it, we've logged it. And this is also the bit that negates the change management boards because it goes through the code review. So the people that actually know what this application does, people can have an opinion that makes that is valid, can weigh in on it. And then the other thing I wanted to point out, Javier, is we did have a comment in the chat talking about the use of .env files, to kind of accomplish the same thing that you're doing with Convict, where each variable is defined, what it means, where it's used, and what values. And then I will add one more bit and then turn back to you. Some people might be asking why we're using bash scripts here. And the point was to make this more accessible, because I think everybody can remember the first time they were faced with a Kubernetes manifest or faced with a Kubernetes Helm chart, and you just run them because that's what you do. Understanding comes later. So with this, since the ultimate goal is to run containers, we wanted to break it down to the simplest way possible to start a container that illustrates all the things that the orchestration tools like Kubernetes or Nomad do for you.
That's right. Yeah. And so this is kind of, this is where we're like, oh, are we actually respecting 12-factor here? Because we're checking in files related to our infrastructure into the same repository that our app is. But I just want to kind of draw attention to the fact that it's in here as I've actually put it in the wrong place in this demo. Sorry, just a moment. Let me back out here. And it's actually supposed to live right next to the application folder. So I'm going to go ahead and fix that right now. it actually should live right next to the application folder. And for that reason, I think it doesn't really, because it doesn't get built into the thing that you eventually deploy, right? Here it is right here. It doesn't get built into what you eventually deploy. And so it still gives you that flexibility of, providing different configuration to your application based on the same like built artifact. But what it does is it lets you put that stuff through your code review process. And these are specifically stuff about what your team owns. So you're in a lot of microservices environments, you're responsible for the provisioning, management, and running of your database, for example. That's the most common piece of infrastructure I'll see in services. So having them in a separate repo kind of creates this more cognitive load where you're not able to look at those config changes in the context of changes to your application, and it can all kind of go out at the same time. So what I've done here, moving on quickly because I want to make sure that we get through all this in time, is I've added some other sort of necessary config variables. So this is all related to the, this schema. I'm defining everything that's in this schema here. And I've added those config variables here. And these are one of those examples of those like things that we know and things that we can put in our configuration file and discuss as a team. So we know that we want our application to run on port 4000 regardless. That's going to get, proxied elsewhere. But the next one that I'm going to put in is the other type of configuration, which is this configuration that's either secret or you don't know it when you're writing the code. And here we're going to do something, again, that's just kind of for the sake of the example. But we are going to use the console key value store as kind of a stand-in for some type of configuration management system that's outside that any application coming up in the deployment environment can access. So what I'm doing here is I'm setting the PG host. So this is the host name of the Postgres database based on what a query to the console key value store for a specific key, for this particular key, the messenger DB host. And then what I'm going to do is I'm going to set that same variable in the container, just like I did with everything else, and say, okay, this is what the Postgres host is going to be inside the container. So if we kind of fan that out to the full set of variables related to our database, it's all going to be the same thing. It's going to be some variable that we need and the instructions on how to pull it from the system when we come up. And this is, again, another thing that we can put through code review among our teams to make sure that we're doing it right as we work on our application. So I'm going to use the same method to provide that to the container at runtime. Then the other piece of infrastructure that we have is this RabbitMQ thing. And this is an example of where this is infrastructure that we probably don't own. In a lot of companies I've worked at, the message queue, like all the brokers and RabbitMQ should be set up for high availability and all of that. That's managed by another team entirely. It's not part of the infrastructure that I own and my team manages. And so that's a situation where we definitely need to kind of have, they need to say, okay, this is where we've registered the configuration for an AMQP equals RabbitMQ in this situation. We've set it up at, in the config store, and it's available at AMQP host. So you can go and pull those up, and the application, when it comes up, can ask, okay, where is RabbitMQ? How can I connect to it? And then we go out and we get that information, and then we provide it, we inject it into that container as it starts up. So this is kind of a full configuration file, again, in this sort of fake conceptual type of deployment file that we're making. And then I'm going to go through and real quick set up the one for the database, because we also manage the database. And this one is going to be where we'll set these variables here. And this is more of a stand-in for, usually this would be like a Terraform file where you're provisioning a database and setting things like, you should put, once you're provisioned, you should put what your configuration here. And so this is very similar. It's just, this is the type of deployment config that we know, like we know what port we want it to run on. We know what the base user should be. You should note that I'm putting passwords in here. I'm just doing that for to keep this example tight. The next session in Microservices March is going to talk about secrets management, but just know that this is not something you should ever do. You should be using a dedicated secrets management platform, and how you actually get that information into the container is going to depend on the tools that you're using, but it may not be an environment variable. It might be something a little bit more secure. So this is just for simplicity, and we never do this. So we've got that container starting up with the variables. In this case, everything that we have here is known. And so we're going to then, after it comes up, it's going to say, all right, register all the stuff that you just came up with that outside source, so that the application that depends on you can ask, where's my database when it comes up. So a good example might be port here. So we set port. We want this Postgres database to be running on the default Postgres port. We inject that port into the container as it starts up to configure the actual database. And then after the database is up, we go ahead and we set that key, that messenger DB port key, to the same value. And then we can see when the application comes up, PG port, it goes up and it asks the system, hey, what's the value of messenger DB port? I need to know that so I can start up. So that's kind of the full setup here. I'm going to run some quick commands to mimic a similar file for the RabbitMQ. And then we'll go ahead and we'll build our app into a container. So this is a stand-in for, this would be your CI system. So we've gone through, fake code review and all that stuff. And now we've built it. And then I'm just going to run that deploy script. And it's just as simple as running a bash script. And you'll see it's registering those keys with that outside configuration system. And then I'm going to start and we can see it up. We can see that the messenger DB primary is up. So that configuration script, deployment script ran correctly. And then we'll go ahead and deploy messenger. And these are all the results of those requests to the central config store to figure out, sort of where things are at. And if we look up here, we'll see that messenger is happily up and running too. So next step, and I'm going to move a little faster because it looks like we're sort of a little short on time. The next step we're going to do is the provision of, so that kind of handles all of the configuration practices and this practice of kind of putting that infrastructure that's owned by your team right next to the application code, because those two are like the only service that uses the messenger database is the messenger service. So having those together is kind of the pattern that I've seen. And now we're going to talk about how we're going to put that behind that Nginx reverse proxy and load balancer. And to do that, we have to understand a little bit about how Nginx does reverse proxying. So this is the basic configuration that you would give to Nginx to do a reverse proxy. So you define an upstream called, and you give it a name. And then you kind of, at this point for Nginx open source, you have to hard code all the servers here. So these are individual servers that are running. And then Nginx is going to, when it gets something that matches this location, it's going to just route to a named upstream. So this is what proxy pass does. And so that's just going to round robin between those two, one at a time. It'll hit first one, then second one, then first one, then second one. So we want that to work for us here for routing to Messenger instances. And in order to do that, we're going to first have to have Messenger register itself with console's service discovery when it comes up. So in order to do that, I've already written the code for this. And if you want to check it out on the blog or in GitHub, you can do so after the fact. It's nothing groundbreaking. It's just a little bit too much JavaScript to get into right now. But all I've done is import the file I've written and just called one function that says register to console. But in order to do that, I'm going to have to add more configuration. So in order to register itself with console, the application needs to know where console is. It needs to know what name it needs to register itself under. So I'm going to add some more config to that configuration schema, specifically the name. So that'll be under console service name, and then just basically where it can connect to the console host. And because I have added more configuration, I need to go modify that deployment script to have some of that second type of configuration where it's kind of, we hard code it and we put it through code review for some environment. And then we also, just depending on, this is one of those things where in a lot of cases, you do have to have something that you depend on being on the host. So in a lot of places I've worked, like that basic piece of information, like where is console, is kind of provided as an environment variable on the host. So we're taking it from there. And then we'll use the same strategy to inject this all into our container when it runs. And I'm going to go ahead and rebuild it. So this would be like one change, right? This would be one round of code review, and then one run through CI, and then we build a new container and then release it. So let's see here. Looks like I've not got a Messenger thing up and running. So now we can use that new deploy script to deploy a few instances of Messenger. I'll deploy like 4 of them. And then if we go to the console UI, you should see that there's, in the services, we've got Messenger services coming up, and they're going healthy. So they're coming up and they're slowly passing health check. And then, so those are all up. So now we just have to set up the load balancer to go between them. And so I've set up a deploy script for the load balancer. And this deploy script, again, since we're kind of running low on time, I'm not going to go into it too much, but it follows the same pattern that we've been going through, just console host, console port, and it's going to start up an Nginx container. And it's going to be using a tool called console template to track changes. Like when we deploy new instances of the Messenger application, it'll go ahead and query this set of servers in console, and it'll get the new set, and it'll automatically template a new version of this config with the upstream. And here you can see there's some templating language here. And this is, again, something that there's a blog post that accompanies this, and it's probably a little bit better to digest in that format. But basically, it'll follow this and go, here and say, okay, what are the IP addresses? So we see we have 172.19.09.10.8.7. So it'll go through and template those all into the Nginx configuration file, and then restart Nginx. And Nginx, when it's not restarted, but when the config is reloaded, it will actually do so without incurring any downtime. So in that case, we'll have a seamless transition to it being aware of the new servers. So here we'll run just a quick health check against the Messenger servers. They all have a health endpoint, and we'll see that they're returning okay. And if we take a look at this upstream host, it'll take a moment to start rolling through, but we'll start seeing, so you'll see it's rolling through the different hosts that we defined here. So as new instances come up or go down, they'll be added to that pool or removed from the pool. And now our next step here would be to register this information, probably not localhost in a real situation, but register, here's where you can find the service, the Messenger service load balancer sort of entry point. And that's how any services that depended on the Messenger service would be able to get in touch with that and use it as part of their configuration. So with that kind of brings us to the end of our planned demo. Jason, do you have any final points for us?
None. I think you covered it quite well. And we try to answer the questions that we've had so far via the chat. And I guess the other thing is just to encourage people to play with it and break things and try and learn from it. Because I know for myself, I've learned a lot by doing this work with Javier.
Yeah, and we'll get to some of the other questions, as we move into the Q&A. But yeah, so that was kind of the overview of things learned with microservices and the 12 factors. So thank you very much. Now maybe we'll kick it back to Jen to talk about, or are we doing Q&A now?
Yes, let's transition into Q&A. It looks like we have 3 questions pending. Jason or Javier, have you had a chance to peek at them, or do we want to just take them in order? We'll toss them up on the screen and answer them.
Yeah, let's take them in order. I think I've been seeing them out of the corner of my eye.
All right, why don't you just go ahead and do the little send it over thing. Yeah, there we go.
Well, sorry, I'm going to go in reverse chronological order here, but I thought this question was interesting. So, we got asked, isn't it better practice to have infrastructure files in a separate repository or having all files related to the app in the same repo? I'll go back to what Jason said at the beginning of the presentation. Whatever works best for your organization is the best thing. In my experience, if we think about, again, going back to infrastructure, in a microservices environment, your team kind of now owns infrastructure in a lot of cases. So I managed an application, for example, that had a Postgres database. It also had a Kafka topic that it managed. It also had a S3 bucket that it provisioned. So it would go out, and our team would run our team was responsible for running the Terraform scripts to set up the Postgres database. We were responsible for defining all the users in the database, all that stuff. So that was all on our product team. And so if we needed to ship a feature that involved maybe, for example, scaling up the database, we wanted a larger database in AWS, that would be our responsibility, not the responsibility of some database team. And in that case, having that Terraform script right next to our application, because no other application cares about that database, only ours. And so having those changes where we go in and we say, okay, we're adding this big query here, and you can see in the same pull request that we are scaling up the database, that was valuable, because then we could talk about it in context and say, all right, that size of database will be okay to handle the increased CPU that this query is going to inject into the system. Now, if you had a team, that database wasn't managed by your team, then yeah, maybe having it in a separate repository, because microservices is really about organizational stuff. So if that works better for having that on a split, then that would be the best practice for that case. Sorry, Jason, did you have anything to add to that one?
Yeah, the only thing I wanted to add to this is, something that comes up a lot when I started in business was the concept of internal customers. Like, oh, these are my internal customers. And I think the best thing for this is, you treat everybody like a consumer of your service. And whatever you've decided are those clean contracts, those interfaces between you and the rest of everybody else's code, that's what you maintain. So if you're responsible for the database or you're responsible for the message queue, then I would advise like putting it somewhere where it makes sense for you, because you're selling a full product.
Sweet. All right, let's I want to make sure we don't miss the questions that were added first. So let's look at this other question about, and this is one where I actually don't know. Oh, I don't know how to push this one to the screen here. Oh, here we go. Sorry, everyone. This question of 3 more factors being added to the 12-factor guidance, I'm not aware of these. Jason, are you aware of them?
So yeah, I was going with the canonical 12 factors, but I have seen it, like I have not really done a deep dive. There are other places like extending there's posts on extending the 12 factors, adding additional factors, and for the purposes of this, I kind of want to stay true to since we're doing like a 10-year retrospective look back, I wanted to stay true to the 12 factors. So I just kind of push those other ones to the side.
Yeah, and even as we were talking about this, we were thinking like, okay, what are the 12 factors of microservices? Like that was the conversation we had, and we don't have a formal document on it, but like we were thinking about like, okay, 12 factors of microservices. Like there are base requirements now with the concerns that microservices bring to your operations about, okay, you need to, the simplest one is use a container orchestration system. You don't want to be worrying about how to schedule containers across hosts manually. Things like your application should expose a health check or a heartbeat endpoint, like things like this that are specific to microservices. Like there's certainly room for extension. And because these are all guidelines, it's kind of nice because you can kind of pick and choose what works for your, they're not a set of rules. They're a set of good ideas that get you to a certain good result. So certainly I'm sure that there's lots of room, lots of little tidbits that you could incorporate into your particular company's version of 12 factor that would have benefits. We had another question here about whether maintainability applies to infrastructure or quality of code. And I don't know, I think, Jason, do you have a comment on the infrastructure part? I can talk about the code quality part.
I think go ahead and talk, because I think what you're going to say is going to apply to me as well.
Yeah. So I think that in general, like we saw that there was an example of now product delivery teams are having to worry about infrastructure more because we're responsible. We have cross-functional teams. We're responsible for delivering a single feature end to end. And so maintainability, I think, is not like the infrastructure is maintainable and the code is maintainable. It's holistically all together. Can our group of people manage this in a way that is stable and scalable and resilient and all the things that you want? And I saw a good talk, I forget, I think it was by Sarah May, who talked about maintainability being kind of like living with roommates, right? Like you are working with a group of people. And if you've ever gone to someone's house where they don't take off their shoes when they go in the door, that's something that works for that group of people, right? It may not be what works for you, but it's, you know, it's, so maintainability I found through my experience is more about for the people who are involved in the maintenance of your application, what is the thing that works best? And in terms of the configuration stuff, I don't think it gets too much into the actual, when we talk about code quality, we're talking about, you know, is the logic understandable? Can I add more code without breaking code that I had before? That type of stuff is, I think, is a little bit at a lower level. The injection of the configuration, making it generic, can help with that. But I think that the actual, when people talk about code quality, that's maybe one level lower, I think, than the 12-factor app deals with.
So the only thing I'll add to that, and you know, we talk, one of our open source projects here at Nginx is called Mara. And one of the things we try and do with Mara is we talk about focusing on protocols over products. And what that really means to me in terms of this question is to not paint yourself in a corner. Don't make design choices that have an obvious point where they break. And again, this is, you know, I love the roommates analogy, but this is kind of one of those things where you would discuss with your roommates, like, what we want to do in order to make sure we can move things forward if things happen.
Cool. All right, let's go. Oh, we've got someone asking us about how to configure console. What backup plan do you suggest for console in case it's down? So one thing I want to preface this with is that I used console in the example because it's a good sort of, it plays the role of some configuration management system. Definitely people use console in the second way I showed it, as a service discovery thing. You know, you register your service with console and then, you know, everything else can tell if it's up or not. You can use their DNS that they give you. The configuration part, there might be better tooling for that. Configuring console for high availability is a very complex topic. And actually I believe there was a Roblox outage that happened maybe 2 years ago that was really big. That was about console. But the short answer is it's really complicated to have a really high availability setup for console. And that the answer to that question in a good way is kind of outside of my personal expertise, because I was more on the web application development side rather than the, you know, scalability engineering side. But I would just point you in the direction of HashiCorp provides good general guidance on how to set up a high availability console cluster. And the same principles apply to setting up high availability console as you might see given to, they're generally high availability principles, and also anything that works on the Raft consensus protocol, such as Kafka. So, you know, Kafka, Zookeeper, I'm not sure if Zookeeper is Raft, but it's the same kind of high availability model where you have brokers and you elect leaders and you have a certain replication factor. Cassandra is another example. So those are all areas that you can look at for practices on keeping these things high availability.
The only piece I'll add to that is, you know, when I was responsible for operations, the advice given to application developers was to be able to fail safely, to have a failure mode that if I can't get to console, if I can't get to Kafka, if that means we can't do work, let's come up with something that we can show the users that isn't a cryptic error message they're not going to understand.
Yep. Okay, I think we have time for one more question, and I really like this question that came up here from Todd. I haven't, did I push it? Did it go? Oh, it didn't go. There we go. Code as infrastructure makes some intuitive sense to a person who has performed development work. how would you explain this to someone who has no development experience? So I don't know, Jason, this seems like a good one for you. Not that you don't have development experience, but that you kind of come from the other side.
Yeah, this is the thing where with junior people in the group, and even some senior people who haven't hit it before, this is where I found that seeing is, you know, like basically going through examples and saying this is how we set up a system using development or using infrastructure as code. And the point that I find that the most pain for is understanding that the whole, I want stateless containers, because everybody is always, when infrastructure code, the biggest problem I've encountered with people is what happens to my database, what happens to my backing store. And so getting down the we decouple that. That's decoupled away from what we're doing. And then for things like we're doing a database, we have a different pattern for that. So, you know, I don't have an easy answer here. But I will say that Hashi's Terraform, like their walkthroughs are really good. And Pulumi also has some good walkthroughs where they take you through the process of knowing nothing about infrastructure as code to standing things up to modifying things.
Yeah, and also from like a basic, like, you know, logical perspective. Like if you're not using infrastructure as code, it means someone has gone into, for example, the AWS UI and clicked around and set things up, right? And it's set up in a certain way. And so if you have these couplings between, like, obviously your application depends on a database. And so you have these things are coupled. And at that point, you have two places that you need to look. You need to look at your application code to understand how it's interacting with the database. Then you got to go to AWS and understand its UI and dig in and find out what you need to know about how that's set up. So the two things are separate, and you have to know the other one exists. And you've got two sort of like paradigms to work on. Whereas when they're both sitting there in the same repository next to each other as siblings, and you know, it kind of gives you one place. Okay, I can look here, and as long as I understand where everything's put, we can understand how it's intended to be set up. And then the other benefit that you have is because it's in source control, you kind of have this history of how things change. So you can say, all right, so this problem started happening on this date. That was the date that we reconfigured the database to have 4 more replicas. Maybe that's the issue, and that's all there in the Git history. So that's one of those are sort of the benefits that I've had from like troubleshooting outages in production and stuff like that. All right, we have one more question. I got permission from the powers that be to do one more question here. What I would miss in the 12 factors is the security aspect highlighted. Is that not important? And maybe we should go back to the 12 factors here and talk about how these relate to security. I think a lot of this, I mean, there's maybe, Jason, if you have thoughts, but what my thought with microservices in general is there are definitely some sort of, I mean, it's all trade-offs. Security, this is the thing I learned about security when in working closely with them for a few roles, is that it's, you know, it's all trade-offs and it's all attack service, right? And so with microservices, you get some benefits because, you know, things are more split up. So if someone gains access to one service and is able to exploit it, you can potentially wall them in. They may not gain access to your whole valuable database. They get access to the one database of the one application. But on the other side, like, you've got more services, your attack surface is greater. So it's all sort of trade-offs. As far as which of the 12 factors, I think the 12 factors generally have security as a precept, but I don't have a great answer on, because of my lack of experience with security, I haven't ever implemented one of the 12 factors. I mean, configuration, I guess, would be the one which is next unit. You should stick around for the next microservices March unit, which is about secrets management. And so the third factor that we talked about today does, like, by decoupling that from the application, it allows you to be more secure in your handling of secret values.
Yeah, and I guess what I would add to that is, and I think that security is obviously important in our industry, and I view security as being something that the organization does that transcends the 12 factors. Like, I don't I don't like it when security is added as a bolt-on, because that implies it's in some way optional or some way isn't a first-class citizen. So if you said, let's go through the 12 factors and talk about security, I think that I could come up with, Codebase. How do we secure our code base? How do we secure our dependencies? So like, do we make sure that the hardware is patched? So I think security permeates all of these. Like it's something that's part of your culture. If you have a culture of security, then you can view the 12 factors through that security lens, just like I could view these 12 factors through the operational lens of how am I going to get these things actually running somewhere, or Javier, how am I going to build these things?
Yeah, and I think, if we were to spend more time thinking about them, like just thinking about this issue of dependencies, for example, like with a 12-factor app tells us we should, define our dependencies and keep a list, use semantic versioning, have this lock file. Most dependency management systems now have a lock file, so that feeds into security too, right? You test on some version, and you test on some version of some dependency that you have, that now gets locked with that version there. And if it's back in the bad old days, you might have something that would just install the latest version all the time. And so if an exploit comes into the latest version, you're exposed to it immediately. Whereas when you've got that, it's another term and it's kind of different. It's a newer thing, but this idea of a software bill of materials that ships with your application, that stuff is all known to you before you release it, and you can understand, am I on a version that has this newly discovered exploit? And you can know that from looking at your Git history. So things like that are things that kind of are security-minded things that come with the 12-factor. All right, we have run over time. So I think, Jen, if you want to come and wrap us up.
All right, so if you're joining us live, we'll be staying on to offer office hours for the hands-on lab. If you're not joining us live, if you're watching this later on demand, we'll be cropping the video off shortly. So what you're going to do is click in the resources box on the screen you're on right now. It'll be highlighted underneath, and there will be a link in there for completing the hands-on lab. It'll be the top link. So you'll click that link and it'll take you over to a page to launch the lab, which requires you to create an account using the same email address used for your Microservices March registration. It takes roughly 30 to 40 minutes to run through the lab start to finish. It is a timed lab. So we have given you a 50-minute time from start to finish. So if you spend a little extra time reading, or you need to step away for just a quick moment, it won't time out, but it is that hard stop. We have a limited budget, so we can't leave it open. And then you have 3 attempts. So if you've budgeted time to do it right now, hang out with us on 24. We'll just go off camera and stay here until 10 o'clock Pacific time. If you have questions, you can just use the webinar chat. And what we'll do is we'll either Jason or Javier will come on screen, do a screen share, walk through your question. So I suggest everyone leaves on 24 up so you can hear any Q&A that's happening. And then once you get logged in, this is what the UI looks like in Instruct. So you'll have a terminal that's in your browser. You'll see in the upper right corner of the terminal, there's a progress bar that shows you how far you've made it through the lab, and it'll have a countdown timer. And then on the right side of it, there's a pane for the lab guide. And what you can do is you can drag that little bar to the left and right so that you can enlarge it if you like. And then the left side of it will be where you're running your commands. And then once you get through each, they're called challenges, there will be a series of challenges. So you get to the end of the instructions, and it'll tell you to click the check button. And if you've done everything that was in the instructions for that challenge, the check script will run. It will say, good job. It'll move you to the next challenge. If you haven't done everything, it won't let you move on. And then once you get to the end of it, you do need to make sure you click done and finish to close out the lab, or else the system won't measure you as having actually completed the lab. And if you're interested in qualifying for the badge, that is a requirement.